Imagine a planet 635 light-years away from us. A planet where day and night can last forever, and oceans cover most of its surface. This planet is Kepler-22b, one of the most intriguing exoplanets discovered in humanity. It has everything it needs to become the new Earth, yet its mysteries could turn it into a world beyond our wildest dreams or nightmares. What secrets does this distant planet hold? And what kinds of life could evolve under its unique conditions? Get ready to embark on a fascinating journey to one of the most enigmatic planets in our galaxy. The Goldilocks Zone. In 2011, while exploring the cosmos, the Kepler Space Telescope made a groundbreaking discovery, a planet in the habitable zone of its star named Kepler-22b. The telescope used an indirect detection method. Every time a planet passes in front of its star, the starlight dims slightly. These small changes in starlight are identified as planets. This method, called the transit method, also helps determine a planet's size, orbital period, distance from its star, and even the potential presence of an atmosphere. The parent star of this Earth-like twin dons the name of Kepler-22, and it's approximately 635 light-years from Earth, equivalent to about 3 quadrillion miles. It's a yellow dwarf, similar to our Sun in size, radius, and age, estimated to be about 4 billion years. However, Kepler-22 is about 20% dimmer than the Sun, making it invisible to the naked eye from Earth. The distance between Kepler-22 and its planet, Kepler-22b, is remarkable. The planet's orbit is about 15% closer to its star than Earth's orbit around the Sun. If Kepler-22b were in our solar system, its orbit would lie between Earth and Venus. In that case, the Sun's intense radiation would likely turn it into a scorching, lifeless world resembling Venus. But the situation with Kepler-22 is different. Its star's luminosity is 25% lower than the Sun's, so Kepler-22b receives less heat than Earth would at a 15% closer distance to our Sun. Thus, temperatures on Kepler-22b could be similar to Earth's, assuming the planet rotates around its star in the same way as Earth does around the Sun. However, if Kepler-22b's rotational axis is tilted like Uranus's, which practically lies on its side, the climate could be extreme, altering between harsh winters and scorching summers. But what if this planet is tidally locked? That would mean one side always faces the star while the other is in perpetual darkness. This kind of distribution of light and heat creates unique conditions across different parts of the planet, possibly determining where life could emerge. Let's delve deeper. On the illuminated side, conditions might seem most favorable for life. With constant light from the star, oceans could stabilize temperatures and prevent overheating. In this environment, living organisms might adapt to eternal light using processes similar to photosynthesis to harness energy. However, there's a catch. If the planet is dominated by water surfaces, evaporation on the light side would intensify, creating a greenhouse effect. This vapor could exert significant pressure on the atmosphere and form dense clouds, leading to severe storms and extreme temperatures. Such conditions could be highly unstable for complex life forms, making survival challenging. The dark side. Imagine a world of eternal night, inhabited by terrifying creatures adapted to life in absolute darkness. Under the reign of cold and shadow, there is no sunlight we are so accustomed to. Could life even exist in such conditions? At first glance, it seems unlikely, but Earth has already proven otherwise. On the dark side of the planet, organisms could rely on chemosynthesis, a process where energy is derived from chemical reactions rather than sunlight. Similar microbes have been found on Earth in deep-sea hydrothermal vents. these could form the basis of ecosystems feeding on chemical compounds rising from the depths of the planet. Furthermore, over time, animals on the dark side of the planet might develop luminescence, producing light to attract food or communicate in the perpetual darkness. This bioluminescent glow would become a crucial survival tool in a world where sunlight isn't available. Still, it's hard to imagine complex life forms evolving on the dark side. While Earth hosts unique creatures in deep ocean trenches and regions with prolonged polar nights, we have yet to discover other life forms elsewhere in the universe, so for now, we can only hypothesize. The Terminator Zone, a place of balance. And finally, the most intriguing place on Kepler-22b is the Terminator Zone. This is the area where the planet's light and dark sides meet, creating intermediate conditions. Scientists believe that this could be the most comfortable region for life. The temperature in the Terminator Zone may be stable enough to sustain liquid water on the surface, provided that the planet has an atmosphere. Thanks to the balance of heat and cold, the water here could remain in a liquid state, forming rivers, lakes, or even oceans. Intense evaporation from the sunlit side and cooling on the dark side could create a climate where life could thrive. It's possible that the first forms of life could originate in the Terminator Zone, gradually adapting to other parts of the planet. Just as Earth's creatures have adapted to the polar night and ocean depths, life on Kepler-22b might eventually spread to areas of eternal light and darkness, developing unique adaptations. Although conditions on Kepler-22b remain a mystery, the tidal locking scenario presents numerous research opportunities. Whether on the sunlit side, the perpetual night, or the Terminator Zone, each area holds unique potential for life. However, scientists believe that the Terminator Zone is the most likely candidate for sustaining complex ecosystems. Future exoplanet research might one day uncover the secrets of worlds like Kepler-22b. And who knows, perhaps we'll find the first extraterrestrial life in this zone of balance. Assuming Kepler-22b has an Earth-like atmosphere with moderate greenhouse effects, surface temperatures could reach a comfortable 22 degrees Celsius. However, it's also possible that the atmosphere has a significantly different composition or is absent altogether. If the atmosphere is missing, surface temperatures could drop to -18 degrees Celsius. But if the atmosphere resembles Venus's dense carbon dioxide-rich environment, the surface could heat up to a scorching 460 degrees Celsius. Fortunately, studies suggest that Kepler-22b might have an ocean capable of stabilizing temperatures, similar to how Earth's oceans have regulated its climate over billions of years, by storing heat during summer periods and redistributing it evenly. It's also believed that Kepler-22b might have an abundance of water. Much of the planet could be covered by an ocean averaging 160 feet deep. While this might seem shallow compared to Earth's oceans, remember that Kepler-22b is 2.4 times larger than Earth. Therefore, your first challenge upon arriving on the planet might be finding land, which could be even scarcer than on Earth. If you do manage to find land, another challenge would be moving around on it. The planet's second unpleasant surprise is its gravity. Planet gravity. Kepler-22b is about 2.4 times larger than Earth, and scientists estimate it to have 36 times more mass. It's true, its gravity would be roughly 6 times stronger than Earth's. If you weigh 175 pounds on Earth, you would weigh 1,050 pounds on Kepler-22b. Standing upright would be almost impossible, let alone moving around. Don't forget about your spacesuit, which typically weighs 290 pounds. On Kepler-22b, it would become a 1,700-pound burden. Before we could travel to this planet, Earth's engineers would likely need to develop specialized exoskeletons to support your back, legs, and arms, alleviating the immense strain on your body. Otherwise, without such technology, your journey might end as soon as you exit the shuttle. And don't even think about falling. Be extremely cautious around any depressions in the ground. Tripping and falling into even a small ravine could mean you'd never climb out, as the freefall speed could reach over 120 miles per hour. Falling 160 feet, you would reach the bottom of the ravine in less than a second. Gravity wouldn't just affect you, it would influence all living things on the planet. Plants on Kepler-22b would likely be short and stout, with thick, sturdy stems to withstand the immense pressure despite limited growth. Leaves and branches would be dense and compact, reducing the risk of damage under constant strain. To anchor themselves and provide stability, the root systems of local plants would probably be complex and deep. This structure would enhance their resilience, allowing the plants to maintain their form and survive in high gravity conditions. The only organisms that might reach impressive sizes are algae, which would be buoyed by water and therefore less affected by gravity. However, you shouldn't rush to dive in and confirm this. Since scientists cannot fully confirm the existence of oceans on this planet, the composition of the water remains unknown. Even if the water is present, until samples are procured and analyzed, it's best to hold off on diving. If after some time you manage to adapt to life on Kepler-22b and stay there long term, be prepared for more frequent birthdays. A year on Kepler-22b lasts just 290 Earth days, making it shorter than an Earth year. But perhaps the most intriguing prospect of exploring Earth's twin planet is the potential discovery of complex multicellular life, a hypothesis that isn't without merit. Life on the planet. If Kepler-22b has an atmosphere similar to Earth's and its axis of rotation resembles our planet's, this would practically guarantee a stable, habitable environment. The planet is situated in the ideal planetary zone, the Goldilocks zone. Not so far that it would be covered in ice, and not so close that it would turn into a scorching inferno. Moreover, if the presence of an ocean is confirmed, it would suggest that Kepler-22b is a world where complex life forms could arise and thrive. The main question is, what might life look like? Given the high gravity, we can hypothesize that living organisms on this planet would be fully adapted to these conditions. Likely similar to plants, they wouldn't grow very large. Instead, they might resemble multipede reptiles that better distribute their weight and facilitate movement. These creatures would likely be short, muscular, and sturdy, with powerful limbs adapted for navigating a high-gravity environment. Their bodies would be optimized to minimize energy expenditure while traversing challenging terrain. To protect themselves against external conditions, many species might develop exoskeletons or tough skin. These exoskeletons would likely be dense and durable, yet flexible, enabling sufficient mobility. They might be made of materials akin to chitin or calcite, but strengthened to withstand pressure and stress. The exoskeletons would serve not only as protection against physical damage and predators, but also help maintain body shape, preventing deformation under gravitational force. In high-pressure conditions, they could also shield internal organs from compression. It's possible that some animal species may use their exoskeletons for thermoregulation, with specialized structures for dissipating or retaining heat, which is especially important if the planet has extreme temperature fluctuations. It's plausible that larger life forms might exist underwater, where the effects of gravity would be less pronounced. As for flying creatures, you're unlikely to see them in the skies of Kepler-22b, again due to the high gravity that would make flight virtually impossible. But these are only speculations based on models and hypotheses posed by astrobiologists and planetary scientists at NASA and other research institutions. For now, we lack the ability to confirm them through observation. However, we hope that future technologies will allow us to study Kepler-22b more closely and perhaps uncover signs of life if it actually exists. If, however, assumptions about gravity prove inaccurate and it's only twice as strong as Earth's, this would significantly increase the likelihood of colonizing the planet. In that case, the only major obstacle for us would be the distance. Interstellar flights. Kepler-22b is 635 light-years away from us. In the context of the universe, this is a tiny distance, but in terms of human capabilities, it's insurmountable. Currently, the speed record achieved by humanity belongs to NASA's Parker Solar Probe. During its close approach to the Sun, it reached a speed of nearly 430,000 miles per hour, or 119 miles per second. While this may seem incredibly fast, it's only 0.064% of the speed of light. Even at this speed, traveling to Kepler-22b would take 992,000 years, a less than ideal prospect, especially if you're not fond of waiting an eternity. To travel such distances, we need an entirely new approach, and NASA scientists are working to address this problem. Specialists are exploring the possible development of propulsion systems based on concepts such as nuclear fission and fusion, which theoretically could accelerate a spacecraft to 10% the speed of light. That is a respectable 62 million miles per hour. Even so, reaching our target would take 6,350 years. For now, we can forget about colonizing such distant planets until we find a revolutionary approach to interstellar travel. These are only assumptions, and we do not claim that this is how things will unfold. We still have much to learn about the amazing life forms that a planet like that could create. Life in extreme conditions on Earth demonstrates that even on a seemingly inhospitable planet, life can emerge and flourish. Now, let's move on to other exoplanets discovered by the Kepler telescope. In the quest for potentially habitable planets, scientists seek out twin Earths, planets that closely resemble our own. A twin Earth is characterized by a size similar to that of Earth, which increases the probability of having a rocky surface. Additionally, it's essential for the planet to orbit a star akin in size and radiation output to our Sun, while maintaining an optimal distance within the habitable or Goldilocks zone. Kepler-452b was the first Earth-like planet found orbiting around a star like the Sun, and it might just be a perfect candidate as a habitable world. Back in 2015, scientists considered it the most Earth-like planet ever discovered, and there's a reason for that. Like the Sun, Kepler-452 is also a G-type star of about the same temperature, but 1.5 billion years older. Even though the star is brighter and slightly larger in diameter than the Sun, solar energy that reaches the exoplanet is just about 10% more than what Earth receives. At 1.6 times our planet's size, there's more than a 50% chance this super-Earth is a rocky world. Even the orbits of the two planets are similar. Kepler-452b is located in the habitable zone of its star, about 5% farther compared to Earth and the Sun distance. Scientists believe that the planet had a valuable head start in the development of life compared to Earth, as it spent 6 billion years in the star's habitable zone. Of course, this is only if Kepler-452b had all the right conditions for life to emerge on its surface in the first place. However, we've recently discovered that Kepler meets some of those conditions. One study shows that if the exoplanet's CO2 concentrations in the atmosphere are similar to the atmospheric amounts of gas observed on Earth, the exoplanet is habitable. So, what would it be like to live in this alien world? Because the planet is more massive than Earth, it would also likely have a stronger surface gravity. In the new environment, people would need to acclimate to their altered weight, experiencing a sensation of being approximately twice as heavy as they are on our planet. Initially, humans would encounter mobility challenges, but over time, we would undergo adaptation, paving the way for the natural course of evolution to unfold. Former NASA's astronaut believes that just like firefighters carrying heavy loads, our bodies would adapt to the new environment, gradually growing stronger. Through heightened physical activity, our bones would develop resilience, countering a potent gravitational force pulling us towards the ground. Over generations, kids would be born with inherently robust physiques, surpassing the physical resilience of Earth-born infants. Not everything, however, would be different. Thanks to its current proximity to the star, Kepler-452b would feel much like home when it comes to sunshine and surface temperature. Planets would still rely on photosynthesis as their primary source of energy, maintaining a growth pace and intensity akin to that observed on Earth. Scientists also speculate the exoplanet might have a thick atmosphere, water on its surface, and active volcanoes. If most predictions are correct, Kepler-452b is a very promising candidate for Earth 2.0. But it might not stay like that for long. Researchers think the planet might experience a runaway greenhouse effect in about 500 million years, the same phenomenon that made Venus a scorching world by trapping high amounts of carbon dioxide in the planet's atmosphere, making it 90 times as thick as Earth's. Still, that's 500 million years, plenty enough time for the human race to colonize it and call it a home world. Kepler-452b seems exciting, but it's not the only Kepler world that shows promise, and it's a really distant one at that. Even light would take 1,800 years to reach this exoplanet. But what if we take the fastest man-made object ever created? Breaking its own speed records as it approaches our Sun, the Parker Solar Probe is soaring at a speed of 120 miles per second. This is a striking achievement, and yet it's still only 0.063% of the speed of light. If we imagine a direct journey from Earth to the exoplanet Kepler-452b, the probe would still require an astonishing 2.8 million years to traverse the vast expanse of 1,800 light-years. "500 light-years away from Earth, within the constellation Cygnus, lies Kepler-186, a red dwarf star. It is this celestial location where scientists discovered the first Earth-sized exoplanet orbiting a distant star in the habitable zone. Since then, astronomers are confident there are multiple worlds in the universe similar to Earth in diameter and could have conditions that would allow for the existence of liquid water on their surface. Kepler-186f only exceeds the size of our planet by less than 10%. With an orbital period of 130 days, this alien world resides towards the outer boundaries of the habitable zone. Because of this, Kepler-186f receives approximately 1/3 of the heat energy the Earth receives from the Sun, rendering its conditions more akin to those on Mars. However, rather than being a misfortune, this disparity offers a unique advantage. Red dwarfs are known to have powerful solar flares, increasing their brightness twice within minutes. But Kepler-186 star is smaller, less massive, cooler, and nowhere near as bright as the Sun. So, even if the M-type star experiences frequent outbursts of radiation, the exoplanet might be far enough to avoid the deadly consequences. The potential for liquid water and the existence of life on Kepler-186f are not solely determined by the planet's distance from its star, but also by its atmospheric conditions. The exoplanet's current position could indicate frozen water on the surface. However, its large size allows for a denser atmosphere compared to the Earth that can retain and distribute heat, potentially warming the water. The 4 other planets within the system are only about half the size of our planet, and all of them have short orbital periods, which makes the inner star companions extremely hot worlds unsuitable for life as we currently understand it. Today, it would take a 780,000-year journey to reach Kepler-186f. But imagine that sometime in the distant future, we invent a spacecraft with a speed limit of 90% the speed of light. In about 550 years, our descendants would step foot on Kepler-186f. What would their experience be like? The red dwarf star Kepler-186 is smaller and about 25 times fainter than our Sun. If you were standing on the exoplanet's surface at midday, the star's brightness would be similar to our Sun's about an hour before sunset. Scientists say the planet maintains a stable axial tilt, enabling it to have regular seasons and a consistent climate, just like here on Earth. Based on calculations, scientists have determined that the axial tilt of Kepler-186f has remained stable for an extensive period of tens of millions of years. Such stability is crucial, as an erratic tilt can have catastrophic consequences, transforming a potentially habitable planet into a barren and inhospitable world. Think of Mars, where an unstable tilt might have played a key role in shaping its current unfavorable conditions. The search for the perfect Goldilocks planet continues, and some of the best candidates are often found by chance. In 2020, Kepler-1649c was accidentally discovered during a review of past observations, after initially being misclassified as a false positive exoplanet. Scientists still don't know much about this world, including what its atmosphere could be. But since Kepler-1649c receives 75% of starlight compared to Earth, and because of its much shorter orbital period of just 19.5 days, it might have temperatures similar to those we experience here on our planet. If Kepler-186f lacked a heat-trapping atmosphere, its surface temperatures would be around -38 degrees Fahrenheit. Although this may not seem favorable, Earth's temperatures without greenhouse gases would also be lower, around 0 degrees Fahrenheit. Even if the atmospheres of the two planets were similar, Kepler-186f would still require more greenhouse gases to compensate for this difference. Many other worlds in the cosmos bear resemblance to Earth in terms of temperature or size, like TRAPPIST-1f, TRAPPIST-1d, Teegarden-C, and TOI 700d, and these exoplanets are located much closer to us. So far, Kepler-1649c seems unattainable. The vast expanse of 470,000 years of travel time lies between us. But when time comes, it would be a worthwhile journey, as none of these nearby planets can match the unique combination found in Kepler-1649c. This extraordinary exoplanet not only potentially shares our planet's temperature and size characteristics, but also resides comfortably within the habitable zone of its star, making it a truly exceptional discovery. The star system has a second planet called Kepler-1649b that's roughly 8% larger than Earth, but located much closer to the red dwarf. Because of the quite unusual 4 to 9 orbit period ratio between the two worlds, there's potentially a third planet hiding in the system. Soon enough, next-generation observatories will give us more clues on the habitability of these worlds. Meanwhile, we'll explore yet another impressive celestial body lurking 1,100 light-years away in the constellation of Lyra. Every 112 days, Kepler-442b orbits a K-type star at about half the Earth-Sun distance. Such a close proximity might lead to multiple issues for the well-being of any potential life forms present on the exoplanet. Typically, planets that orbit close to their host stars become tidally locked, resulting in a potentially harsh environment on their surfaces. However, Kepler-442b is situated just outside the range where the star's gravitational forces could cause tidal locking. K-type stars are generally dimmer compared to the Sun. Additionally, Kepler-442 itself is a smaller and cooler star, so the exoplanet around it finds itself in an optimal position, approximately 0.4 astronomical units away from its relatively tranquil host star. Scientists consider K-type stars as a sweet spot in the search for habitable worlds. Although they aren't as bright as G-type stars and not as long-living as M-type red dwarfs, they offer a favorable combination of properties. Only within 100 light-years of our Sun lie at least 1,000 K-stars. These orange dwarfs can exist between 15 to 45 billion years, and throughout the entire lifespan of our Sun, which is about 10 billion years, orange dwarfs only gain approximately 10 to 15% in their brightness. All the while, our Sun can make the Earth uninhabitable in a mere 1 to 2 billion years. So, how promising is Kepler-442b? Astronomers like to categorize planets based on their potential habitability. The updated scale, called the Comparative Habitability Index, improves upon previous methods by considering multiple factors. It takes into account the planet's composition, favoring rocky planets, as well as the eccentricity of its orbit, which affects the stability of light and heat received from the star. Additionally, the scale considers the albedo, which measures the amount of solar energy reflected by the planet's atmosphere. These combined factors play a crucial role in determining the habitability, even in cases where the orbit is irregular. Just like the Earth Similarity Index, the Comparative Habitability Index ranges from 0 to 1, with a higher value indicating a higher potential for habitability. On both scales, Kepler-442b has been assigned a value of approximately 0.84. Unfortunately, the exoplanet is too dim and small to be directly imaged with our current telescopes, let alone travel to Kepler-22b, which would take 1,700,000 years on the fastest space probe ever created. What we can do, however, is look at its biosphere. In one study dedicated to examining radiation levels received by potentially habitable exoplanets, Kepler-22b stood out as particularly interesting. It receives nearly sufficient sunshine to support a significant biosphere that could be detectable by the James Webb Space Telescope. As the JWST studies this world, we might also want it to extend its observation to two other intriguing exoplanets within the same constellation. In the Kepler-62 star system, 2 planets reside comfortably in the habitable zone. The remaining trio of planets in the system orbit too closely to the K-type star, causing them to be excessively hot and unsuitable for sustaining life. Scientists find Kepler-62e and Kepler-62f particularly intriguing, as they are potentially water-rich worlds. These exoplanets have Earth Similarity Index rankings of 0.83 and 0.69 respectively. Kepler-62e completes an orbit around its star every 122 days, while Kepler-62f has a longer orbital period of 267 days. The atmosphere of Kepler-62e is believed to be densely clouded, and the planet is thought to have a consistently warm and humid climate, extending even to its polar regions. These conditions make it an exceptionally favorable environment for supporting life. A study from 2014 suggested a possibility of a large moon in orbit of Kepler-62e. If that's the case, the odds of the exoplanet being a habitable world would increase even more. This is because large moons are necessary for the evolution of complex life. Through tidal forces, they help regulate the planet's rotation and axial tilt, which has a direct impact on its climate patterns. Moons also provide a protective shield, deflecting or absorbing potential impacts from asteroids or comets, thereby safeguarding the planet and its inhabitants. Although a further located Kepler-62f would mean cooler temperatures on its surface, it still holds potential to be life-friendly. But even if this hypothesis holds true, envisioning a technologically advanced civilization seems challenging, given the absence of land, metals, and the fundamental element of fire. Processes like metallurgy, vital for technological progress, would seemingly be unattainable. Nevertheless, nature's complexity opens a possibility of creatures far more inventive than ourselves, capable of finding alternative ways to surpass our current technological achievements, perhaps even if they live underwater. If humanity decided to send a message on board Parker Solar Probe to any intelligent extraterrestrial life possibly inhabiting these strange worlds, they would receive it no sooner than 1,850,000 years from now. But if we sent a radio signal today, it would reach the 2 exoplanets in a mere 1,200 years, blink of an eye on a grand cosmic scale. While Kepler-62e and Kepler-62f are no ideal twin Earths today, the ever-changing nature of planetary systems holds the promise that these worlds can undergo transformative changes. Our own planet was once entirely submerged in oceans, and yet over time, it transformed into a diverse world of both land and water. Researchers contemplate the future development of these exoplanets, speculating that they too may eventually evolve into environments reminiscent of Earth, with a harmonious interplay between expansive lands and surrounding oceans. Meanwhile, even here on Earth, we have something as weird as flying fish, so it's not unreasonable to assume that were living organisms to exist on these 2 exoplanets, they could be quite sophisticated. One of the biggest challenges in studying distant worlds has been the vast distances involved. However, we may not have to wait for super advanced telescopes to address this challenge. Data from Kepler and the European Space Agency shows that among all Sun-like stars in the universe, half could host potentially habitable rocky worlds, and some of these stars could be lurking in our cosmic neighborhood. This means there's a 95% chance of at least one twin Earth hiding somewhere within 20 light-years from us. How long do you think till we verify a completely habitable world in a close vicinity of our solar system? And how will this discovery change the course of human history? Let us know what you think in the comments. Make sure to stay tuned here to learn more about our planet and the cosmos. Thanks for watching.